Good day. I'm Martin Gagel with Market Radius Research. It's Tuesday, May the 31st, and we've got CEO Dan Blondal of Nano One Materials Corp. Nano One is a developer of low-cost, high-performance lithium-ion cathode materials. It's great to have Dan back to get an update and dig into some of the recent news. While the last 12 months have been a bear market for small cap green and clean tech stock, Nano One has continued to provide positive news flow. Last week's announcement of the acquisition of Johnson Matthey Battery Materials Canada seems to be the piece of information that many investors were looking for, demonstrating Nano One's progress in developing its cathode business. That, along with today's BASF co-development announcement, it's clear that management has been very busy putting together many strategic pieces into place. But please remember, this is neither a recommendation nor investment advice. We're here to learn about the company. Dan, thanks a lot for joining us. And just to start this off, as a quick recap, can you give us a very brief overview on Nano One and some of the key milestones you've achieved over the last few years?
Great. Well, it's great to be here, Martin, and thanks for the introduction. For those of you new to Nano One, maybe I'll do that quick kind of overview. We are a technology, an industrial technology company developing a process for the manufacture and the fabrication of lithium-ion battery cathode materials. So that's the most kind of complex and expensive component of a lithium-ion battery. It comprises maybe about 50% of the cost of a lithium-ion battery. And that's because it contains the critical, like lithium, nickel, manganese, cobalt, or lithium, iron, and phosphorus. We've developed a platform technology that can make a range of different cathode materials, manganese-rich, nickel-rich, and iron-rich materials to serve different parts of the market. And ultimately, what our technology does is it reduces the complexity, the cost, and the environmental footprint of making those cathode materials. And it is disruptive to the lithium-ion battery supply chain because it can use alternative sources of lithium, nickel, manganese, and cobalt and eliminate waste streams and byproducts that at this point are encumbrances the adoption of those supply chains, particularly ex-China in North America and Europe. So that's a very kind of high-level overview. As a technology company, we are looking to commercialize our technology through licensing, joint venture, partnership, and even independent production of cathode materials. Really, all of the above are recipes for the adoption of our manufacturing technology across the spectrum of cathode materials worldwide. So it plays a large role in a lot of the decisions we're making and a lot of the announcements that you've seen coming out recently.
All right. I guess since it's the news of the day, you just announced this morning your joint development agreement with BASF. Why don't we start with that and just give us an overview on what's happened there? Is that similar to the other JDAs you've signed with other of your big global partners?
Yeah, I'd say I'd put it in the same category. It's been in the works for a while, as these things tend to be. There's relationship building and materials testing that all happens in the background for months or sometimes even years in front of this. We essentially, what this joint development agreement is, BASF have a series of cathode materials. Particularly, we're going to be particularly focused on their high energy density cathode materials, and using Nano One's one pod and metal to cam, M to cam process to make those materials. So we're bringing together their material innovation and our process innovation to make those materials, to make a better, cheaper, faster, cleaner cathode material at the end of the day. And so this joint development program will start with some initial testing, really down at the kind of a gram level, working up to the kilogram level, ultimately for successful into commercializable volumes of materials in pilot plants, et cetera.
BASF is a major global supplier, and they've got a bunch of cathode materials they sell already. Is roughly the plan is to find a better way, a more efficient way, and I think in the news release it says without as many sort of excess materials, or just finding a better way to create the products and maybe improve the cathode, the CAMs that they're manufacturing right now?
Yeah, well, so let me take a step back and just describe one of the big problems that we solve with our one pot process. So we use sources of, let's say, nickel, manganese, and cobalt, and lithium that do not that are sulfate free. Basically, we're not bringing an intermediate nickel sulfate chemical, for instance, into our process. Which means we don't generate a whole bunch of sodium sulfate waste or byproduct out of the process. So we eliminate a really large byproduct stream that is largely today having to go into landfills or into really expensive recycling steps in order to recover some of the chemicals that are therein. We completely eliminate that with our one pot process, and that's one of the attractive things about this deal for BASF and for other parties that we're dealing with, because we eliminate this big sort of environmental sort of hurdle that the world will have to face as we scale up into millions and tens of millions of tons of materials.
And is that sulfide step, do they put energy and money into first creating the sulfide and then going into the cathode material, or do you kind of just buy the sulfide?
Typically, when the battery metals are mined, it depends on where they come from, but they'll usually go through some kind of a refining step with sulfuric acid involved, and it's all mixed, purified, refined in that step. And right now, the way it happens is that material is converted into a metal sulfate, nickel or manganese or cobalt sulfate, and then sent off to a cathode producer, who then combines them with caustic soda. This is a bit of a chemistry lesson, so sorry. But they combine those to produce the nickel, manganese, cobalt precursor that's needed to make cathode. And all of the sodium, all the sulfate comes out in the form of a sodium sulfate waste stream. It's 2 to 3 times as large as the product stream itself. So it is a very large byproduct, and there isn't it historically has been used for fertilizer and for detergents, but those markets are completely saturated. So there's nowhere for this material to go except landfills and recycling. And so that's the inherent problem in the supply chain that we're trying to solve with our process. So with our process, we can go direct from metal powders or carbonates or hydroxides or a number of other different materials that don't require us to process a sulfate. And so the sulfate stays upstream in the refiner in where it can be recycled and reused to continually dissolve metals and create them, pure and battery grade metals. But ideally, we leave that at the refiner, and then what we take into the cathode space doesn't actually have this kind of this byproduct or waste stream that's generated from it. So that's one of the really big value propositions that's at the root of the work we're doing with BASF and others.
I'm about to ask about the Johnson Matthey acquisition. Is it coincidence that this BASF announcement came a week after roughly the acquisition announcement? Was that sort of a catalyst for this, or are they kind of independent? Although I presume some kind of this facility you're developing is a needed part of the roadmap.
Yes, so they're independent. These deals have been worked on separately and in confidentiality as well between the two groups. But the timing just happens to be kind of the way it is. It's fortunate that we believe that we're coming together like this, because it does tell the same story. BASF, of course, we're working specifically on nickel and manganese-based materials. With the Candiac acquisition, our initial efforts will be on lithium iron phosphate, so in a different chemical realm. Both of them are leverage our one pot and our M2CAM process to reduce waste, complexity, and environmental footprint in the supply chain.
All right. Well, let's move on to the acquisition. Why don't you give us a quick highlight overview on that, and then we can dig down into a couple of the elements on it.
It's probably worth my while just winding the clock back a little bit to this time last year, or kind of going into and coming out of the summer and into the fall. At that time, we were beginning to put the wheels in motion to set up shop in Quebec, specifically to go after the LFP market that we felt was emerging in North America and around the world. We hired Denis Geoffroy, who happened to be the ex-general manager of the Candiac facility. He left there in 2019. He was, to give it context, he was one of the original employees at Fostech Lithium in the early 2000s that developed the lithium-iron phosphate process and was behind the first commercial production of LFP in 2012 kind of timeframe when they built the first Fostech plant. That was then subsequently acquired through a series of companies, ultimately ending up in Johnson Matthey's hands in 2014. And Denis continued on there as the general manager and then left in 2019. We brought him on board really to initiate an LFP push in Quebec, largely because that's where a lot of the talent is, that's where the supply chains are, and we felt it was going to be a center of gravity for lithium iron phosphate and ultimately other cathode materials. And then, 10 days later, Johnson Matthey announced that they were going to exit the battery space. And so what we had as plan A got shelved, and we went after plan B, which is really an opportunistic take on the ex Fostech plant, which is the JM plant in the Johnson Matthey plant in Candiac, Quebec, just southeast of Montreal. And what that allowed us to do is, of course, acquire a plant with all the equipment that we needed and a whole bunch of really experienced people and the permits and all the systems that are needed for automotive quality manufacturing of cathode materials. So we saw that as an opportunistic acquisition that would allow us to really accelerate the plans that we had already started in Quebec as well. So a bit of a long story, but I think it's important for everyone to understand our thinking was well in place here before Johnson Matthey even put it up for sale.
So can you just quickly go over what does the acquisition include and not include in terms of what you're acquiring? You mentioned it's cash-free, debt-free basis. You get the building, the property, you take over the employment agreements with you're buying the equity, not just assets. Is there IP you're getting in on that? Sorry, I threw a whole lot out there, but if you can sort of what comes and doesn't come with the deal.
So just for your listeners, because there's often confusion about this, cash-free, debt-free means we're buying a company with no cash and no debt in it. So that's the and we're buying their business. We are paying $10+ million for that business, but the books come with no debt and no cash in it. So that's what that basically means. Pretty straightforward. It includes, of course, the people, the team, the land, the assets, and all the systems that are needed to manufacture cathode materials in that plant. So that's kind of the basic package of what we're getting. I think what's most valuable to Nano One in all of that is really the cumulative years of experience in scale up and manufacturing that exists at that plant. Many of those people were there with Denis back before 2010 as they were developing the technology and as they commercialized it and built the plant and did the startup and got it all running. So they've been through this before more than once, and that experience is worth its weight in gold. It's very complementary to what we do here at Nano One in Burnaby, because we're largely process innovators and they are largely scalers and producers of cathode materials, and those two skill sets come together very neatly. So for us, that was one of the biggest objectives. Of course, the equipment gives us a really big head start, and the permitting and the systems as well, because it's there and it's in place and it's working, and it will largely be useful for us for our technology and our way of making LFP.
So like you've got Burnaby or BC and Quebec now. Is Quebec seems to be the development or the scale up technology more later stage in the R&D process, while Burnaby is more of the scientists and lab coat kind of process work?
Yeah, it's a good way of splitting it up. I think we see BC really as the innovation center where the technology is born and nurtured, and we see the facility in Quebec as being really the next stage of development. We will continue to do small pilot and testing with our customers out of our Burnaby facility, but Candiac will be about scaling that to larger pilot, debugging things. There'll be some innovative work going on there, and the team there is very excited about getting back into that kind of innovative spirit. But they'll be doing that at more of an industrial scale than at really the sort of the basic foundational scale. So we'll have an innovation center, we'll have a commercialization center for all extensive purposes, and it will start with LFP because that's a natural fit in Candiac. But our technology, the one pot process, is a platform, as I said, for making LFP, NMC, LNMO, different cathode materials. So we envisage that facility becoming a platform and a launch pad for all of our chemistries as they go into larger piloting and commercial scale phases of their life cycle.
And I just want to highlight that there's a big difference between you have your the Burnaby's 1 ton a year kind of facility, and then scaling up in big industrial processes. That's a big deal. You need a lot of expertise, not just to get it done, but to do it efficiently and effectively so you get the economies that you're looking for. That's no mean feat, is it?
No, it's huge learning curves, and you can, you just have to look at any kind of battery plant that's starting up anywhere in the world, how long it takes them to get rolling and how much waste there is as they get rolling and as they commission everything. It takes years and years, and because there's this huge learning curve, how to work with equipment, how to make it efficient, how to reduce how to improve the yield and reduce the waste. Those are all part and parcel to scaling up and commercializing and turning on a factory, and having people there that have done it before. It's invaluable learning lessons that will cut months, if not years, out of the startup cycles.
And JM has existing production there. You are not going to be continuing along with any of what they're currently producing, are you? You're just shutting once the sort of transitions happen, you're shutting that down and it's all focused on developing the Nano One products, right?
So maybe just to give that a bit of history. So Johnson Matthey have customers and contracts with those customers that they have to fulfill. They are making lithium iron phosphate there using the hydrothermal process. And once they have completed their obligations under those contracts is when we will do the handover, and when those contracts are basically finished and terminated, because really they're their contracts, they're not ours. We need to build relationships with some of those customers and some of the customers in their pipeline. While we're doing that, we will be converting the facility there from its hydrothermal origins to a one pot process. As I said earlier, all the equipment is there that's needed to build our one pot process. There's some replumbing work that really has to happen, but we think we can begin trials pretty quickly and determine how the equipment operates under kind of a one pot process, and that will then dictate how we engineer a more integrated solution at the plant.
And when you say you can do that pretty quickly, does that mean like Q1 2023, like they hand it over at Christmassy, or is that sometime in 2023?
That's the estimate of when we think we'll be in there. There are obviously a number until they close off their production at JM. We don't have we won't have the final details, but our ambitions are to be in there in the first quarter of 2023 and beginning the trials of our materials at those kind of really large volumes, thinking of it as a really large pilot proof. And then once we have a sense of how that works, that will then dictate how we engineer it, and how we operate the equipment for active piloting and ultimately small production of at kind of commercial scale sellable materials. We don't know how long it's going to take quite yet. There's lots of engineering work. Timelines on that will need to be figured out over the next 6 months, and we'll be able to come with a considerably more detail as the dust settles on this deal, and as we're able to work more closely with the engineering teams at Candiac and get in the facility to test it under the one pot process.
Can you give us any, like you say, all the equipment's already there, any sort of ballpark dollar value as to how much you have to invest it to kind of hopefully get it up to your kind of commercial proof?
Yeah, it's a great question, and look, there's lots of engineering work still to be done here, and it's all active right now. What I can tell you is that it's well within the what we have in the treasury right now, and it doesn't materially impact our multi-year runway. So we may, so we will still end up with a multi-year runway after we've kind of outfitted things there to run one pot. We just don't know the exact cost, and there's lots of engineering work to be done there. So in due course, we'll bring that out, but we're pretty confident in our ability to convert and get things up and running.
And can you, how big is the facility? How much capacity does this facility, obviously you'd have to buy more equipment and so forth, but maybe on a square footage basis, how much capacity could sort of theoretically go through the Candiac facility?
Yeah, maybe just to give you a sense of it's about 80,000 square feet. Let's say the building, it's multi-floor, so it sits on about 45,000 square feet. I think the building itself. For those of you who've been to the Nano One facility, that's 3 times our footprint at Nano One. And so that's just the footprint, and then of course you double that with the multi floors there as well. So it's a lot of space. There's warehouse space, obviously to work within. There's a whole bunch of equipment there that we don't need, and that will create room for further expansion as well. And then on top of that, the building is sitting on a parcel of land that allows us to expand and create sort of full-scale production as well. We haven't made any decisions to do that yet. Johnson Matthey always had plans to expand their facility onto that land, and we will be looking very favorably at that as well, because it's right there next door.
And this facility is going to be a multi-cam sort of proving grounds. I don't know if that's quite the right term for it. And so your different chemistries in there. So is it once that you kind of get the LFP process pinned down at sort of industrial scale, then you'll build another facility or then you can easily, it's a lot easier to license it out at that point, and then you'll switch it over to a different chemistry, or can you kind of trial out 2 different chemistries at the same time, or is there more a sequential process? Get one done, move on to the next one.
It's going to be a bit of a yes, kind of to all those kind of questions. It'll be a balance between what we do here in Burnaby and what we do at the facility in Candiac, and we will continue to do piloting here on all of our materials, but at a scale that's really kind of only we're making kilogram quantities of materials for evaluation with our partners. That's kind of what allows us to do all the sort of original business development work. But when we get to proving these materials in commercial batteries, we need the larger volumes, and we will start with LFP. We will eventually build out the capacity either in Burnaby or in Candiac to do larger volumes of materials for prototyping in commercial batteries. And that will be done with all of the materials, LFP, NMC, LNMO, all of the above. And then the LFP will continue to operate in the larger facility there until we've actually commercialized it elsewhere, and then we'll sort of cookie cutter that into these other materials, into these other facilities, whether they be located, on the facility on the land there, or with partners, let's say elsewhere in the world. Again, how that all unfolds is still to be a story to be told. But the key thing here is that as we shift, as LFP grows up into larger production, it will then free up the equipment at the Candiac facility for use with LNMO and NMC and the one pot process for other materials as well. Does that make sense?
Yeah, that makes sense. And you have to be kind of dynamic as things progress and other opportunities and things show up. You got to be nimble.
You have to be nimble. It's a totally, this market is still very nascent. Decisions on battery chemistry are still being made at the automotive scale. We're seeing changes in those views, particularly if you look at what happened in what's happened to the whole global supply chain with nickel, and with all the sort of Eastern European and Russian conflict. You've got a total change in the supply chain and a different view now, and a more favorable view of lithium iron phosphate. How that plays out and what the balance is going to look like is anybody's guess. But we're well positioned to address any one of those things. But we have to remain nimble on all fronts to be able to shift with the sands the sands of demand as they kind of move around in the from year to year and month to month.
Yeah, just one last thing on the Johnson Matthey. You were doing some development work on their ELNO technology previously. Is that included in this deal, or is that their IP or
So maybe the ELNO project, a joint development project, actually is much like the BASF one we described earlier. They have this ELNO nickel-rich cathode material, high-energy cathode material that they were developing, and they formed a joint development with us to leverage our one pot process and M2CAM technology to improve its cost structure and complexity and ultimately environmental footprint. All of that work is largely wrapped up now in the last few months. We've kind of wound that down. They have now sold that business as of last Thursday. They announced the sale of that business to EVM out of Australia, and the dust will settle on that in the coming months. And then we'll figure out if there's any work to be done with them on that front, or whether we just we bottle it up and wrap it up from here. So that all that ELNO business is now over in EVM's hands and is not part of this deal right here. However, what I should mention, and it's probably really important, in the last month, we hired out of Johnson Matthey, we hired their sales and their lead sales guy in North America, who actually understands the LFP market extremely well. And he's been working with us now for a month already, and he's starting to develop some of the relationships that he's had with a number of the cathode buyers, and prepping them for the advanced work that we're going to be doing on LFP at the Candiac plant.
When you get Candiac up and running, is that product from there, will that be able to be qualified by the end battery maker? So they say, yes, we see it's at industrial scale, good to go, and either you produce it out of there, or then like theoretically it can be produced out of a different facility. And what does it take for them to be like to have that qualification process? Just like what are the main hurdles to hit qualification?
Well, listen, you got to be able to make materials repeatedly the same, and that's certainly a very important part of it. They have to demonstrate that you have the ability to troubleshoot, and that's part of the systems that need to be in place. So you have to have all this sort of product troubleshooting and product introduction pieces in place, and a lot of that's already here in Burnaby, but we have to formalize it, and they've already done that in Candiac before. So really formalizing those processes is really important to the battery manufacturers and the automotive companies, and seeing that it's formalized gives them the comfort that you're going to be able to deliver the quality and the consistency and the performance out of your materials on a day-to-day basis. So those are really key parts to have in place, and that comes with this deal with Candiac. Of course we have to rebuild it with a one pot emphasis, but the systems are largely there, and that's going to be very important to the large scale producers. They want to see that you can actually meet their needs, obviously, and be able to scale up to larger volumes before they can commit. And the ability to demonstrate one pot running at multi-thousand ton capacity is a first really big step in that direction.
All right. Are you able to, I'm curious, like your LFP cathode that you'll hopefully be selling shortly, can you give us just like, I don't want any sort of like strategic information given out, but what's the rough, does it sell for $1 a pound, $10 a pound, $100 a pound, like kind of just a broad scale of sort of the market value of what that goes for?
Yeah, so lithium iron phosphate, the cost, first of all, the cost is largely governed by the cost of lithium carbonate. So lithium carbonate dwarfs it, because the iron and the phosphorus, even though they're critically very important, they don't sort of drive the cost. So it's largely driven by the cost of that, and it's the cost of the process to make it. So as lithium prices have gone up, of course, we've seen a huge spike in LFP prices as well. The typical cost, we measured in kilograms, but typically LFP, depending on where it is, whether it's in China or North America, and what kind of taxes and VAT and all that kind of stuff are applied to it, is going to be in that range, probably between $15 to $30 a kilo, maybe even higher, even up to $50 a kilo, depending on the markets. There's virtually no LFP production other than what's being done at Candiac right now outside of Asia, outside of China for that matter. There's very little cathode production. So the demand is high, the prices are high. So there's a short-term opportunity here while volumes are low to get in quick, benefit from healthy demand, and then scale up from there. But that's kind of those are roughly the prices that we might see. It's kind of in that tens of dollars of kilos, probably up to 50 or even higher for niche applications that absolutely require a specific kind of LFP.
All right. I'm running out of questions here on Candiac and LFP specifically. Is there anything we haven't touched on that you want to make note of?
No, I think maybe one of the other really important things here is what's happening in Quebec. We've seen, and in Canada for that matter, right? And maybe you're going there here with the
I was going to go there anyway. So since you brought up, let's go. How is the whole Canada mines to whatchamacallit strategy going?
Mines to mobility is what the feds are calling it. And look, Quebec has been investing in the battery supply chain, the battery ecosystem for many years, and that's one of the reasons this talent exists. It's one of the reasons that Fostech came into being very early on, and why LFP, the first LFP cathode materials were made in Quebec, in the world, and so that investment is what attracted us to begin our commercial efforts in Quebec. Since we've made that initiative, and since we started bidding on the JM deal, one of the things that happened is a lot of the Canadian and Quebecois efforts to bring in anchor investors, keystone investors into the supply chain have happened. BASF was announced and as well as POSCO and GM in Bécancour, Quebec. So that's about 2 hours north of Montreal. And we also heard about, of course, Stellantis and LG in Windsor, Ontario. And I expect there are going to be more sort of strategic investors coming into Canada, and we welcome those. These are fantastic things for companies like Nano One, because these companies need technology. They need local feet on the ground and local technology to really kind of drive some of the initiative they're trying to put into place. We see it as an opportunity to work with these players to improve the environmental footprint, get rid of the sodium sulfate waste stream, and make a much more sustainable, stickier, longer lasting, resilient supply chain that competes in Canada and North America, even against some of the low costs and low prices in China. So these are really fundamental to what we're doing. So we have a very active initiative with the feds and with the provincial government in Quebec, here in BC, and of course in Ottawa. With the aim of building out that supply chain, not just for Canadian consumption, of course, but also for North American and foreign consumption of cathode materials. So that's a very key part of our initiative here.
Yeah, because you recently hired Adam Johnson, your head of government affairs, I believe, right?
That's correct. Yeah,
and that's to help. And Canada and Quebec, we're trying to, like, Canada is a huge auto making nation, and countries like us and Germany are really scared, like, oh, are we gonna, like, it's way easier to, or way simpler in some sense, in a mechanical sense, to build EV cars than all the transmissions and ICEs for legacy cars, call it. And so there's a huge initiative by the government to make sure that industrial base it will transform into jobs for the 21st century.
Yeah. Well, listen, don't underestimate the complexity of making a lithium-ion battery. It dwarfs the current complexity in an internal.
It's just totally different skill set than making an 8-cylinder engine versus making batteries. Yeah.
So that transforming that labor, that skilled labor that exists today in the automotive sector into something that's going to work for batteries in the electrification space is a big challenge. Transforming the supply chain is a big challenge, and it's not just about putting the car manufacturing in place. The batteries and everything that goes into those batteries really has to feed into that. And as we've seen deglobalization and localization of supply chains, the repatriation of those into North America, Canada, it becomes critically important for us to not only have the mining and the car production in place, but also everything in between. So that's the refining, the cathode production, the cell production, the pack and battery production. They're all key components to this. We see Canada as an ideal jurisdiction to be doing really the front end of all of that, which is the mining, the refining, and the specialty materials, going into some batteries and some cars in North America, in Canada, but also going into batteries and cars in the US as well.
Yeah, and then with your IP platform, hopefully your technology is being used in Europe and Asia and elsewhere.
Yes, that's correct. That's correct.
Yeah. Should we, on your NMC and LNM and other technologies, can you maybe give us an update on how that technology is progressing? The LFP is obviously likely the first commercialization, but just talk about the other chemistries and the state of the world on those and your development in those technologies.
Yeah, well, I think we've kind of covered LFP in spades.
Yes.
The one thing is that really the automotive sector, other than, we've heard announcements from Tesla, we've heard announcements from GM and Ford and Volkswagen about kind of going in the LFP direction. And we expect that with this announcement on Johnson Matthey, that will bring a fair amount of credibility, and that will open doors with many of these organizations to discuss, future, obviously future collaboration and possibly a production of materials for their batteries. But that's all still kind of happening and coming into play. Obviously, more news on that when we can bring that forward. The LNMO batteries, which is the cobalt-free, nickel, manganese-based cathode materials. We sometimes call it the high-voltage spinel. Our listeners will know that is reliant very much on a high-voltage battery, the commercialization of high-voltage batteries, which isn't quite there yet. But in the coming years, we expect that to become more and more prevalent, and we expect to see commercial high voltage batteries coming into play, and that will then feed into demand for our LNMO product, which we are testing in fairly large volumes out of the laboratory here in Burnaby with a variety of players around the world. So we're quite optimistic about our LNMO. However, the market hasn't yet to emerge for the batteries. And then on the NMC front, by and large, our proposition on the NMC front is quite disruptive. We're saying, okay, well, instead of making it from nickel sulfate, make it from nickel metal, and that disruption is seen, of course, in the face of everything that's going on globally, worldwide with the supply chains, but also it's an extremely competitive field in the NMC market, whether you're talking about China or Japan, Korea, Europe, or North America. So we're developing relationships with manufacturers like Johnson Matthey, although that one is coming to an end, BASF and other players. But we're also working at the bookends of the supply chain with the large integrated miners and junior miners, and we're also working with the automotive companies to create demand for our technology, particularly in the NMC field, where the change is the largest, the change that's required is the largest, because we're kind of stuck on this method. The world is stuck on this method of making NMC materials that's actually quite wasteful, and we have technology that resolves those waste problems, but it requires change. Fairly significant change, and it's going to require the backing and the vision of these large companies on either end of the supply chain to drive what happens in the midstream. So, let's kind of the long story short is we are developing all of these relationships with the intent of creating demand for our NMC related solutions, and that's all about driving down cost, complexity, and environmental footprint in those areas.
Gotcha. And with the NMC and the LNMO chemistries, is the market going to be roughly segmented where sort of the basic standard EVs are going to be using LFP technology, and then the Ferrari Porsche types are going to be using the more specialized chemistries that are more expensive for specific adaptations, or maybe in a pickup truck where you need a lot more power or extended power range in that?
Yeah, look, I think the high nickel materials are largely going to be focused on, we'll call it luxury, long range electric vehicles, and the big pickups probably fit into that when you're paying $100,000 for them, right? That's kind of where they fit. LFP, I think, is better suited to the mass market sort of entry level side of things, and this is where traditionally LFP was focused on the more industrial side, where let's say buses, fleet vehicles, taxis, forklifts, industrial storage of renewable energy. That's where LFP really shines, because the duty cycles there are very heavy. That material needs to be, that LFP is the safest, longest lasting, and cheapest of all the cathode materials, but it doesn't have the energy density that's needed for the long range vehicles. But in the mid range and the entry level, it makes a lot of sense, because the entry level electric vehicles they have to be low cost, and to be low cost, they have to have small batteries, and a small battery then has to be charged more often, and LFP can stand that. NMC can't. So LFP is a kind of a natural choice for that part of the market, and we've been talking about this for years. We're certainly on record about it, and we are beginning now to see the OEMs realize that those mass market vehicles are going to probably have to be LFP, and then transitioning into their more expensive models where they perhaps have higher margins, they're able to bring in the longer range NMC materials.
With the auto OEMs, like everyone has little bits of technology here. Everyone's trying to make their tax stack, call it, as big as possible to have as many sort of barriers or moats around their business. How involved are, let's say, the OEMs on your, like the actual the particular chemistry of an LFP, or do they just buy a battery pack off of LG or someone else, or where are they picking to invest their core IP in? Is it in your area of the battery or some other part?
We have development programs on cathode materials with a number of different OEMs, and so they're certainly very interested in developing those materials, and they're also obviously very vested in the development of battery packs. Like how do you make them smaller and lighter and stuff more between the wheels? That's going to be incredibly important because that'll drive down weight, which will improve the energy density of the battery packs. And driving down the waste is also very important. The environmental footprint, the CO2 footprint are paramount to the OEMs and to the big integrated miners as well. And so finding ways to do that are going to be important. And you can't just bootstrap existing methods to do that. It requires technology investment. And that's why we have engagement with these large multinational corporations is they see that, they realize that has to happen. They realize they're big changes and it takes time, but we hope to bring more partnerships and investment ultimately from these parties in future technologies like this.
You have a lot of partnerships with a lot of big global companies. You're still pretty small in sort of size-wise in the scheme of things. Like, how the heck do you manage all? Like, you're talking with BASF one day and other, like the complexity. How much more complexity can you handle? And given that people are coming to you, can you maybe start charging them or having like sort of upfront fees or something to get this development done work, since you got to manage this complexity and you seem to be adding some very prospective value to them?
Yeah, listen, some of the development work that we're doing, even some of the joint development work, is actually paid for. So we have a little bit of money coming in. It's really kind of called engineering cost recovery, right? So it covers our internal costs. But it's only to the tune of, like $500,000, $1 million. It's not these aren't like massive investments or anything, but it's skin in the game. It means they're committed. And I think that's a certainly very important part of the of what we're trying to do. At some point, Martin, we're going to have to focus. We're probably going to have to carve off some of the deals that aren't going as quickly. In fact, we have done that already. We did that in China with Puli last year. We really saw no future, and particularly with some of the geopolitical stuff that's going on with China, it made sense to just to hive that off. So I think you'll see that from us from time to time. We'll hive off certain initiatives that really don't make sense and concentrate on the ones that have the most momentum. So that's going to be really important. At some point, we are going to have to focus, but for now, we believe in our one-pot process and our multi-cam strategy, and to do that, we have to be working with a variety of different partners around the world, and throw a lot of spaghetti on the wall, and a lot is sticking right now, and it's keeping us really busy. But yeah, we will have to refine that list at some point. Look, ultimately, we're trying to license our technology and partner with everyone we can, because it's about changing the supply chain. We can't just change the supply chain for one player. It won't work that way. One automotive company can't change the supply chain on their own. They all have to be using our technology in order for there to be a significant change in the supply chain and significant change in the environmental footprint. And that's a big part of the strategy. That's why we have to keep working with all these big players at the same time.
All right. Why don't we hit some of the audience questions here? I'm just going to kind of go down the list here. They may not make sense in kind of which order they're
Just one thing, Martin, it occurred to me back when you asked me if there was something else on the Johnson Matthey side, or maybe it's in the list of questions here, but and it has more to do with, because we've been asked this, why did Johnson Matthey choose our bid over others? And I don't know if that's in your list of questions. It probably should be if it isn't.
Yeah, you know what, it was on my list, and then we sort of jumped over that. So yeah, you were gonna tell a bit of the story on how you got there, and yeah, they've got technology. There are other people interested. It doesn't seem like you've spent a whole lot of money. Like 10 million is a lot of money, but it's not a huge amount of money. How did you guys win?
I think at the end of the day, we brought the best hope for the Candiac facility to the table. That's what we did. We came with this one pot process and this vision, this long-term vision for the Candiac facility and its people, and ultimately the customers that are there, and the pipeline of customers that they had. And so that creates goodwill, and it's good for Johnson Matthey's kind of brand going forward, of course, because it shows that it hands it off to a credible player who has a good vision, who can drive down the costs, make the business more profitable, and grow it. And that's an incredibly important part of this. We provided them with a way to satisfy their customer needs and their contractual needs in the bidding process. And I think that was pretty unique. And we also have, as you said earlier, we have a long-standing relationship with Johnson Matthey on EL&O. So we have credibility and trust, and we know the people in the organization. Having Denis on our team, who's former JM, also played a really big role in that. So it's really that trust and that relationship and the credible plan that we had for the Candiac facility and the people there, and keeping the jobs and propagating the business into something that's going to be even more profitable was a really key part of that. So at the end of the day, I don't think the number of dollars we bid was as significant as those other components.
Is it fair to guess that what you're doing and the Candiac facility is strategic to both the federal and the provincial governments, that they were maybe poking their fingers into the situation as well and trying to find a partner that kind of made good strategic sense?
Well, listen, I can tell you, we were talking with them all very directly, but they had no influence on Johnson Matthey's decision. And so that's very strictly government intervention verboten in the process. But certainly there's strong interest from the provincial and Canadian government in seeing it going into good hands. So that was and so they're very supportive, obviously, of the results.
Okay, well, that's good background on that. Thanks. Okay, and yeah, let's move on to some questions here, and in no particular order except the ones that went up first. Hi, Dan. Is Joe Lowry still serving on your advisory board?
Yes.
All right.
Yeah, simple question. Yep.
There you go. Is the BASF deal for high nickel cathode?
It is for what they call their high energy density cathode materials, which are both manganese and nickel rich. So we can't tell you what the chemistries are at this point, but they're nickel and manganese based.
Okay. When is NASDAQ uplisting coming?
I think it's going to very much depend on catalysts and market conditions, something we are continually analyzing. And when the conditions are right, we'll let everyone know.
All right. Where are the raw materials for the Candiac plant coming from, and how many cathode lines can you fit in the existing plant?
The existing plant has one cathode line in it, so that's all it fits.
Okay, you can't squeeze another one in there.
Can't squeeze another one in, no. But on the land, and there's lots of engineering work to do here. We believe that we could put probably, at least 10,000 tons of capacity on the existing land there. and certainly that's well within the plans that that Johnson Matthey had to expand their facility. We believe that's quite doable. Lots of engineering work to be done, and until we've actually done the trials, we won't really know what the existing plant's capacity is using the one pot process. Once we have a good understanding of that, that will then dictate how we expand and what we do in the facility.
So, sorry, as I was reading it, the 10 tons per annum capacity, is that's not off of the one line, that's sort of after build out and so forth, that
well, let me kind of back that up a little bit. So the existing plant there has a nameplate capacity of 2,400 tons per annum using the hydrothermal process.
Yes.
We will convert it to the one pot process, which is our process is less dilute, which means there's more cathode material in the mix when we make it. So we expect that we'll get more capacity out of that plant. It won't be the ideal configuration, but it will work, and we'll be able to demonstrate things in there.
Yeah.
Obviously, we will then take that and make we'll move to a customized engineering design using the one pot process, and we believe that the building block, particularly for automotive scale manufacturing, needs to be about 10,000 tons per year, and that's one line. And so what we would do is we aim to demonstrate at that kind of scale in all materials. Obviously, LFP would probably be first, as long as all the pieces come together on it. And we could potentially cite that in Candiac, but we might decide to do it somewhere else. And there's lots of work to be done before we make any decisions on that.
So the new line that would go in, the plan is just demonstrated at sort of industrial scale, would be to design it for 10,000 tons per annum. Is that?
Well, so our basic building block, would be 10,000 tons per annum. But that's not the existing facility there. When we convert it, will be somewhere in the 2,000 tons per annum scale. But
the next facility build, you're not going to build that, like call it 8,000 to add up to 10,000. You're going to like one unit of industrial.
And then we're basically cookie cutter that. And look, and that's not likely to be done on our own, because people will ask, well, where's the money going to come from for that? I mean, this is all going to be done in partnership and in joint venture type of arrangements. In all likelihood, we will have automotive scale and industrial scale sort of mining side sort of partnered in those kinds of operations. There was a question, I think the front end of that question is, where do all the raw materials come from?
Yes.
So they come from a variety of different areas in North America and Europe, I believe. I don't know. Those are Candiac's details, to tell you the truth, and that's not really up for me to say. I think what I really want to probably project here is where do we anticipate these materials coming from for our feedstock. So we would like to keep them within North America where possible. Phosphoric acid largely comes out of Morocco. That's where the bulk of the world's phosphoric acid is right now, and that's likely where it'll least originate from. There are some junior plays in the phosphate space in Canada. There is phosphoric acid in the US. There's certainly lots of iron in North America, and there's lots of budding lithium coming out of North America and South America. So we would expect the raw materials to kind of come from that kind of grouping of producers or juniors.
And there's not going to be, your raw materials aren't going to need to be special in any way, like it's going to be largely a commodity, and that's part of your whole process, is that you can take on a wider variety of inputs?
I wouldn't say commodity. If anyone is following the battery metal space, none of the battery metals are behaving quite like commodities right now. But look, it's all battery grade materials. It all has to be refined and then purified, down to 99.5% purity, really to get to something that can be used effectively in a lithium-ion battery.
All right. While Candiac is evolving as a proving ground for large-scale production, what level of revenue will be produced to help offset costs? I guess if you're doing smaller scale production and then you sell it off, I'm guessing that's maybe where the question's coming from.
Yeah, look, it's too early to say. Again, the dust is barely settled here. We have a lot of work to do on defining what the capacity of that plant is going to be and who the customer is going to be. We're lucky to have a mitt full of our own partners, but also a whole bunch of pipeline coming from Johnson Matthey and the sales team that was already in place there, who are now kind of actively working for us. So we're already tapping some of those existing customers, kind of bringing them into the vision of what we're going to do with one pot. And look, it's going to take months before we really have a good sense of what that looks like. So stay tuned on that front. Can't make any projections on revenue at this point.
They're handing you the keys, let's say at the end of this year for the Candiac facility, but it sounds like you're already some of the team you're already working with. Is there some sort of a cost sharing, or you're given some direction over, like you're working in partnership with them until sort of the keys get handed over, or what is your relationship like with the facility until the real handoff comes around the end of the year?
I guess first of all, so we have three ex Johnson Matthey, 3 ex Candiac employees who work for us. So Denis Geoffroy, the ex GM, the lead project engineer, a guy named Jan Bernier, he's now working for us, and then Andrew Muckstad, who is based out of Detroit, who was on the sales side of things. So those 3 people are working for us actively. They're ours. But we also have been working collaboratively with the new general manager there for the last few months. And now that everything's announced and their staff and team are aware of what's going on, we already had a town hall meeting with them. Everyone's really excited about some of the changes that are coming, and I think the opportunity to work on a new technology and commercialize something new and exciting and more competitive is a big thing for people there. But in the interim period between now and when we take over, we'll have a sort of a collaboration agreement with Johnson Matthey to use some of the spare time that some of their sort of engineers and support staff have. They're going to be focused. Most of the plant is going to be focused on production, and there will be people some idle time. So we're going to have basically a collaboration type of agreement where we're basically bringing people in for hours a day perhaps to work on engineering plans and commercial plans for the facility. Does that explain it?
Yeah, I think so. There's going to be a transition period. It's not going to be January 1, call it, all of a sudden, hey, the new boss shows up and this is what we're doing now. There's a transition where some of the people are starting to work on your projects, and there's some cultural.
We're already working with their engineering teams, their HR teams, their finance side, their bookkeepers. All of that is going to slowly build up over the next 6 months, and basically through contractual services type of agreement, and so we build that up to the point where we take over, and that enables us to hit the ground running and have a smooth transition.
Okay, that sounds good. With the large market demand for lithium causing huge spikes in spot pricing, how will Nano One navigate the markets in the short term to secure lithium supply without burning through the treasury too quickly?
Right. So great question. There'll be some initial cost in doing trials. Obviously, we'll have to buy lithium to do trials. But ultimately, running the facility there in kind of continuous mode will be done on the back of materials being sold. So that will be largely hedged and managed through that process. They bring the Johnson Matthey team there includes people on the supply chain side, buyers, who understand that market and can bring that kind of expertise to the table. But we also have the likes of Joe Lowry and Bob Morris, who bring a tremendous amount of expertise and know-how in the battery metal supply chain as well. So we will, leverage that, and then we also are building relationships, as I said earlier, with some of the large integrated miners and even some of the junior miners who are bringing lithium online in North America and other places in the world.
All right. Regarding your HVS partners, is the work mainly at the cell level? Do you have a high voltage battery pack platform nearing maturity?
It's a good question. Our high voltage spin-out, which is also what we call LNMO, is under test and evaluation really at all levels, with cathode producers, with cell producers, and even really at the kind of with automotive looking at sort of high voltage cells. The reality is that there are yet to be commercial cells out there. We are talking with virtually everyone in the space on that front, and our materials are testing favorably in a number of them. So that's about all I can say about it. We are not planning to be a cell producer. We make high voltage cells, pouch cells here for testing and evaluation for internal purposes. But when we send the material to someone else, they put it in a different cell with slightly different anodes and electrolytes and separators. So they build their own type of test cells and work from there.
Like Nano One is still pretty small, but you've got these substantial partner. This is my question. Partnerships around the world. When you go to trade shows or phone companies up, do you need to explain to people who Nano One is now, or is within the industry, you guys are pretty well known and understood of at least the general strategy and direction and concept of your technology?
I would say our brand awareness has grown leaps and bounds over the last 3-4 years, and we're at a stage right now where introductions are deep introductions are far less common. So I think by and large the community know who we are and they see what we're doing, and and we've got a lot. You can tell that by the number of reach-ins that are coming in now, right? So we're seeing companies reaching in, saying, "Hey, I've been following you guys for 6 months, and we like what you're doing, and we want to find a way to work together." And so that's so we get more and more in those on a day-to-day basis as really brand awareness grows for Nano One.
All right. How does Nano One compete with other North American cathode manufacturing companies, Mitra Chem and 6K?
So first of all, there are no North American chem producers out there. 6K, Mitra Chem, Nano One included. We are not. None of us are producers. So I just want to make that clear. The only real cathode production that's happening today, there's a little bit of BASF work happening, and what's happening at Johnson Matthey. That's it. There is no cathode production in North America, essentially. So Mitra Chem, a little hard for me to figure out totally what they're doing, but there's looks to be a kind of an AI approach to designing systems and processes for making cathode materials. Not sure they're making them or not. In our case, we have a very practical approach. We are designing the chemical systems and we're putting it into play. I think we're kind of way ahead of them on that front. 6K have designed a way to do the initial firing of cathode materials using basically a very large plasma torch, essentially. We think there probably are challenges from a scaling point of view. I've yet to see how that technology will scale to 10,000 tons, for instance, or let alone 100,000 or 1 million tons of material. So they certainly have some challenges, I think, to prove the scalability of that technology. But we are looking very much at the thermal processing end of things. How can we more efficiently thermal process materials? It's one of the areas where the industry is very inefficient. And I think 6K has come up with a really interesting approach to it. We have similar ambitions to change the way these materials are thermally processed. And in due course, we'll come up with those and basically spin them into our engineering plant design.
And that was part of the work you were doing with Saint-Gobain, right? On the thermal processing?
Yeah, it started there, yes. We've come a long way since those days, but yes.
All right. Can you talk a little about niobium coating? Is it unique, performance improvements, commercialization? I perceive this to be your CAM performance enhancement play, question mark.
Yeah, so definitely our one pot coating using niobium, which forms a lithium niobate coating around the cathode material, around each individual crystal. That is a unique benefit of our system, of our one pot process, to make these coated nanocrystals, and it improves the durability of the material by preventing manganese and nickel from dissolving in the chemistry as you cycle the battery. So that's kind of the idea. Essentially, lithium niobate, which is the coating that forms, is a solid state electrolyte. So it allows lithium to pass through it, but it doesn't allow nickel and manganese to pass through it. So that's the key component of it. We are partnered with another multinational miner, CBMM, on that front, developing the coatings using their feedstocks for it.
All right, and just since you mentioned the solid state, that was quite the buzz thing. They're going to be the next big thing in batteries. What is the state of the world on solid state batteries?
Solid state batteries are kind of the holy grail of, actually, it's not so much solid state. I should say, what really is the holy grail is the lithium metal anode.
Okay.
So if you can actually create a lithium metal anode and make it ultra thin, or have basically, when the battery is fully charged, there's lithium metal on one side and no lithium left in the cathode material. And when you discharge it, all the lithium flows back into the cathode material. It makes the battery ultra thin. But and this isn't new technology; it's been around since the 1980s. It's incredibly difficult to do without catastrophic failure and fire. And when lithium metal catches fire, it creates quite the set of fireworks. So it's a very big challenge to prevent that from happening. So you have to prevent little hairy dendrites from growing and shorting out the battery, and that involves designing an electrolyte that prevents that. And the solid electrolyte is kind of one of the barriers that can prevent those from happening. It's not the only way to do it. There are companies out there that are developing lithium metal batteries with solid electrolyte, and that would be called a solid state battery, or with liquid electrolyte. But there are, and with polymer electrolytes, there's a whole range of different types of systems out there. They're really the only commercially available one is one that's in Quebec, called Blue Solutions. And they've been producing lithium metal solid state batteries for their parent company Bolloré for the last 15 years. So it's been around for a long time, but it's expensive. It's for niche applications. And those are some of the challenges. Lithium metal is expensive, and you have to solve the safety problems, and you have to solve all the interfacial problems, how you connect all these solid things together. And so I would just say that there are many challenges still to overcome. It is, for us, we're agnostic because it still needs a cathode material. So yes. the cathode's the cathode, right, at the end of the day. So we have development programs underway with solid state battery companies, but I do believe there are still many, many challenges to overcome on the safety side, on the cost side, on the production side, and the complexity side of things.
All right. I'm impressed with Nano One's discipline in tapping partnerships and government innovation funds to move forward without stock dilution. Do you anticipate any need for near-term stock dilution to access funding?
It's a good question. I think in the case of government programs to access sort of more non-dilutive money, we're well stacked up in our treasury right now, so we would not need at this point matching funds to drive any further non-dilutive monies from government grants. I think that's what the question was about.
I think so, yeah. And I just like Are you going to have to raise any more money here? But you as you stated before, your balance sheet.
With our current plans, we're not going out to the markets. Right, we have no plans to go to the markets to raise money. But as opportunities develop, we'll see. But certainly in our current plan and budget, no.
All right. I guess a final question. You've been with us a ton of time here, so thanks for that, Dan. What kind of news, let's say through the remainder of the year, should investors be looking out for? I'm guessing some periodic updates on how things are maybe progressing with JAM. Any other just more JDAs, anything else to kind of keep our eyes open for?
Listen, we've always got deals and agreements kind of in the works. Keep your eyes out for those things. I think I believe very strongly that the Candiac announcement and acquisition will bring us considerably more credibility with some of the major players in the space up and down the supply chain. So I think you can expect to see stronger levels of engagement. Of course, we know that strategic engagement in Nano One beyond a JDA is going to be a major catalyst, and we're working hard to put those kind of things in place. And so keep your eyes out for that and progress in that direction. We'll say what we can when we can, but that's a major imperative for us is to build on what we're going to do at Candiac to bring in active partners and maybe there'll be maybe there's strategic investment that comes along with that as opposed to sort of more general capital market stuff. But those are the kinds of things that I think will really catalyze our markets, because it'll bring the credibility to the market. So look, we're always we're hungry for that kind of those kind of relationships, and I think we've moved the needle a lot in the last with the announcements in the last few weeks, and we hope that will drive further engagement.
So, and just to sort of clarify the obvious, you're not going alone on this. You're looking for, as you said, partnerships. This is nobody's going it alone in this industry. You got a partner, because you're, like you said, you're trying to change the whole supply chain, and no one company can do that on their own. Yeah,
look, it's going to take the whole village, essentially, right? Everyone's got to come together here. It's extremely hard to do this for anyone to do this on their own. It requires partnerships. The big players need small innovators. The small innovators need the big partners. If we're going to change the supply chain, we need multiple partners to really sort of drive those kind of changes. And so we need to find ways to bring all that together.
All right, Dan, thank you very much. Thanks for the large amount of time you gave us here to explain what's going on at Nano One. Much appreciated, and looking forward to watching the developments. Thank you.
Great. Well, thank you, Martin. It's been a pleasure, and appreciate the really wide range of questions and topics that we covered today. Thanks.
Awesome. All right. Have a great day. Talk to you later. Cheers.
Yeah.